So, a number of you have asked me about scholarship question number 9. I think what I'm going to do is, so mass 1 is moving up, and then when it gets to a certain point, it's going to keep going up on its own momentum. I think what I'm going to do is I want to find out, first of all, how fast it's moving once mass 2 hits the ground. Then I'm going to figure out how far it continues moving. And before I do that, I'm going to find the acceleration. Now, it does say they're both initially at rest, and mass 2 is 12.5, mass 1 is 3.6. Mass 2 is the winner. And 1g tension. Who's winning? Hey, mass 2g. And then there's going to be a minus tension, a plus tension, a minus m1g, and that's going to be m1 plus m2 times a. So far, so good. Hey, tension cancels. And I'd like to find the acceleration. Well, the acceleration is going to be m2g minus m1g all over m1 plus m2. The acceleration is going to be 12.5 times 9.8 minus 3.6 times 9.8 all over 12.5 plus 3.6. The acceleration is going to be 12.5 times 9.8. Take away 3.6 times 9.8 divided by 12.5 plus 3.6. Now that shouldn't be anything new. We've done this before. A equals 5.4174. 5.4174. My second argument is going to be, how far will mass 1 move? How far will it be traveling under acceleration? Well, it seems to me mass 2 can only fall 3.2 meters before it hits the ground. So it seems to me mass 1 is going to move up by 3.2 meters. Then it's going to change, but it's going to accelerate at 5.4174 meters per second squared for a distance of 3.2 meters. So I'm going to now say A equals 5.4174. The distance we're traveling is 3.2 meters, and initially at rest, VI equals 0. I can find V final by going VF squared equals VI squared plus 2AD. How to get rid of a squared? Square root. Oh, and even better, VI is 0. The speed of mass 1 right when mass 2 hits the ground is going to be the square root of 3.2 times 5.4174. Cool. That's going to be times 3.2 square root 4.1636 meters per second. That's how fast it's traveling when mass 2 hits the ground. Now, mass 1 is then going to keep on going up, but this time it's going up in free fall. This time, we have the following situation. We have an initial velocity upwards of 4.1636. At the top, it's going to be traveling 0 before it comes falling back down to Earth. It's going to be accelerating at negative 9.8 meters per second squared, because it's going to be in free fall. How far will it go before it reaches the top and comes to a stop and starts falling back down? Well, now I can go VF squared minus VI squared all over 2A it's going to be 0 squared minus, need a little bit more room, 4.1636 squared all over 2 times negative 9.8. It's going to end up being 0 squared minus answer button squared divided by 2 times negative 9.8. It's going to go 0.8845 meters. So now that I've done that, I'm going to erase everything on my drawing just so you can get a feel for what this all means. So first of all, this thing is going to fall down to the ground 3.2 meters, which means this is going to start out at a height of 3.2 meters. And it's going to raise another 3.2 meters when this one falls down. So right there, the height is going to be 3.2 meters because it's already starting off the ground, and another 3.2 meters. And then it's going to keep going up. It's going to keep going up because it ends up, since it's accelerating upwards, it ends up with a velocity of 4.1636 meters per second right here. It's going to keep going up. How much further? That much further. So it's really going to be 3.2 plus 3.2, or you could have gone 3.2 times 2, plus that. I hope the answer is 7.28. Let me scroll up. Oh, 8.17. Why am I off here? Now I've got to do some thinking. Pause for a second. Probably by now you've seen my mistake, Mr. Dewick. I figured it out. Right here there's a 2. I didn't put the 2 in here. So arg, this is going to be wrong. This is going to be wrong. This number is going to be wrong. This number is going to be wrong. Good gosh, Mr. Dewick, you never make mistakes. And this is going to be wrong. I need to fix this. So let's try this again. It's going to be the square root of 2 times 5.4174 times 3.2. Sheesh, Mr. Dewick. 2 times answer button times 3.2. Square root this, looks better. Yeah, we're going up at 5.888. 5.888 meters per second. Now what? VI is 5.888 meters per second. 5.888 meters per second. So it's going to be 0 squared, take away answer button squared, divided by 2 times negative 9.8. And I get 1.77. 1.77 meters. So now if I add, same argument, 3.2 meters already off the ground. When this falls, it's going to lift it up another 3.2 meters. And then it's going to go another let's erase the decimal there, Mr. Dewick. It's going to go another 1.77 meters. Let's see if this one works. That number plus 3.2 plus 3.2. Ah, there we go. 8.17. 8.17 meters. Woohoo! Sorry for the dumb mistake. Hope that helps. You made a mistake. Oh, shut up. It's late at night and I'm doing an answer key for you guys. Anyways, I hope that helps.